Okay, before we start this video, again, there are notes online. Go on to the week 3.3 tab on Blackboard, and you're looking at Intro to Linear Systems. So that's what we're going to talk about today. So if you need to, pause the video, and we will print your notes out so you can take notes. Otherwise, be ready to write all this down. Again, these are your notes. You need to be prepared for tomorrow, because when we come in tomorrow, we're just going to start on an activity after the bell ringer. So let's get started. Alright. Again, a system of equations is two or more equations comprised of two or more related variables. Okay? So this right here is system of equations. A system of equations is two or more equations comprised of two or more related variables. Again, the key component here is that, and this is an example of a system right here, the key component is you have to have the same variables. Okay? This would not be a system. If I had 5x plus 3y equals 6, and then I had z plus 4q equals 9, this is not a system. They have different variables. They have to be the same variables. Okay? So far, basically what you've learned how to do is you've been able to solve for missing one variable. Now what we're going to do is be able to solve in order to find out two missing variables. We're not going to be given an x or a y here. We're going to have to find both of those, and we're going to use two equations in order to do that. Okay? If you keep going in your notes, it says the solution for the first equation above is a set of points represented by the line y equals negative 5/3 x plus 2. Okay, let me explain where they got that from. They solved this equation here for y. So this is what you would call it, this form right here is standard form. And that's going to be important to know. Standard form is ax plus by equals c. We'll talk more about that later when we get into depth about that, but that's the form. Basically, you have your x variable and your y variable on the same side of the equal sign, and then your naked number is on the other side of the equal sign. That's your standard form. It goes ax plus by. There's more to the standard form, but for this particular example, that's all you need to know. What they did was they took this equation out of standard form and they put it into slope-intercept form. And that's where they got y equals negative 5/3 x plus 2. But basically what it is saying is, if I graph this equation right there on a coordinate plane or a Cartesian plane, that line is going to represent all the solutions that fit this graph. Okay? That's all the solutions that fit this graph. So when I draw this on a Cartesian plane, every point on that graph will work for this. Okay? And it says the solution for the second equation above is a set of points represented by the line y equals 1/4 x minus 9/4. Again, the same thing. Again, what this says is, if I graph this equation in my calculator or on the Cartesian plane, I'm going to get a line. And that line is going to be filled with a bunch of points, infinite amount of points. Every point that is on that line will work in this solution. That means if I take a point off, that means I'm going to have an x and y. If I take a point off, it's an x and y. And it's on that line, I can plug the x in here, I can plug the y in here, and it's going to make that statement true. Okay, that's what that's saying. That's why you graph equations, because that's your infinite number of solutions. Okay? Now, the solution for the system of equations is the point or set of points where the two lines intersect. This is huge. Okay? I would highlight this on your notes, star this, or whatever the case is. But the solution for the system of equation, if I want to solve this system, again, this is my original system right here. If I want to solve this system, basically I would graph these 2 points, and where those lines cross, they're going to share one point. That's your solution. Okay, that's your solution. Okay, make sure you write that down and have that in your notes. I'm going to go ahead and move the notes up. Okay, and again, I wanted to leave that statement up here so that you see it. The solution for the system of equation is the point or set of points where two lines intersect. That's extremely important. Okay, that's the point of this. This is what we're looking for. The intersection can occur in three different ways. The three different possible solutions can be the alignment of the two lines when graphed on a plane. Okay, that's a whole lot of words to say this. There are only three types of solution. There are three types of solutions for systems of equations. Okay, the first type is this one right here. This right here is called one solution. Okay, this is one solution. It is where your systems of equations intersect one time. Essentially, and this is all important notes. If I'm writing it, it means it's very important. Essentially, they only share one point. So right here, this is called one solution. So one solution is where your systems of equations intersect one time. Essentially, they only share one point. Okay, so if you look here, here's one equation, here's another equation, they cross right there. That is the only point in which they share. No other points match. Okay? This would make them, this point right here, this x and y would be my solution. Finding a solution to a system of equations via graphs is the easiest way to find a systems of equations. So this is the first type. One solution. Okay, take a second to write that down. If you need to pause it, pause it. I'm going to erase it. Let's go ahead and move up to the next one. The next one can kind of look trickier than what it really is. We've already talked about this. We've already talked about this in class, kind of, we touched on it a little bit. The second one here can be looked at in a couple of different ways. Infinitely many solutions. Sometimes people call all real numbers. A lot of times when we deal with systems of equations, we talk about how many solutions does it have. Well, if you ask how many solutions does it have, it's not all real numbers. How many solutions it has is infinitely many solutions. Okay? So here, this is the second type. Again, there's only three types of solutions. This is the second type. The second type is infinitely many. This is when, and I'm just going to write SOE, the system of equation shares every point. Essentially, they are the same line. Essentially, it's the same line, okay? And you can see this on the graph here. If you look closely, and if you have your paper in front of you, you have one graph on top of another graph. Okay? Essentially, they're the same line. When you work this out and you solve for y equals mx plus b, when you solve them, you're going to end up with y equals, an example would be like y equals 3x plus 2 and y equals 3x plus 2. When you graph that, you're going to see they're the exact same line. Okay? That means you have infinitely many solutions. And that's your answer. You would write down, what is the solution? They're infinitely many. How many solutions do they have? Infinitely many. Another thing is, depending on the wording of the question, if I ask you how many solutions it has, you would say infinitely many. If I asked you what are the solutions, you could say all real numbers. Or you could say infinitely many. Okay, they're all the same. Okay? So that is your option number 2. Again, there are only 3 different types of solutions. And then finally, your third choice is right here. You can quickly tell those lines are parallel. These lines do not cross. Because these lines do not cross, they will never have an intersection. They're parallel. They'll never have an intersection. If they're parallel and they never intersect, there is no solution. Remember, our solution to systems of equations is where the graph crosses each other, where they share the same point. In this case, they will never share the same point, so you have no solution. No solution. So finally, the third option is no solution. Graphs will never intersect. And yes, Morgan, intersect, not intercept. Graphs will never intersect. These lines are parallel. Okay. Again, if we remember, parallel lines have the same slope. So graphs will never intersect. These lines are parallel. And that is it. Those are the only three solutions that we have. You can only have one solution, infinitely many solutions, or no solutions. You cannot have two solutions, 5 solutions. Okay, it does not work like that. Okay, now that's the easy part. Okay, identifying how many solutions there are. At some point, we're going to learn, this week, we're going to learn what the solution is. If it has one solution, you're going to have to tell me or name that solution. If it has infinitely many, well, the answer is just infinitely many, or all real numbers. If it has no solutions, you would just say no solution. Okay? And you could write the empty set, 0 with the cross to it. Okay? Make sure you get that down. I'm going to go ahead and move the notes up. Okay, there are 3 types of ways to solve systems of equations. Systems of linear equations can be solved using graphing. Okay, what we would do is we could tie, again, if they had parallel lines, there'd be no solutions. If the line was on top of each other, or it's essentially the same line, they'd have infinitely many solutions. If they intersected, we'd actually look for that point of intersection and identify what the coordinates of that point is where they intersect. That would be our one solution. Okay, the cool thing about this is I can show you a really good way to use the calculator in order to solve this. But first you need to be able to show me how to use it manually. So work on that and I'll show you an easy way to use the calculator. So graphing is one. The next way is substitution. To me, substitution is the longest way, but we're all going to learn how to do it. We're all going to do it. And for some of you, I've learned that a lot of students either like substitution or they like elimination. Most of them do not like both of them. Okay? But there's actually good times to use all 3, and I'll tell you that more as we go about that. And then finally, the last way to solve the system of equation is what's called elimination. Okay? Elimination. That's the third way. I prefer elimination myself. I feel like it's the quickest. Now, there's also a 4th way, which we're not going to touch on yet, I guess, and it's matrices. We can solve systems by matrix. Okay? And again, there's a really easy way. I say it's really easy. There's a really long, drawn-out process in the calculator, but the calculator will give you the exact answer. And we'll talk more about that later as well. Okay? Okay, so another thing that we could do when we solve this equation is if we look at the ideas of graphing, is we could put these points in a table. Okay, we can put these points in the table. Let me go ahead and move that up real quick so we can see this a little bit better. What this problem really wants you to do, and we're not going to kind of exercise that, what this problem wants you to do is it wants you to create a t-table in order to graph these. So you would create a t-table for this one, and then you'd create a t-table for this one of points, and then you would graph it. We're not going to do that. What we're going to do is we're going to do it the right way, because that takes a long time, because I'd have to pick an x value, solve for y, pick an x value, solve for y. We're just going to graph the way that we know how to graph, okay? So what we're going to do is the first line, we're going to go to our y-intercept, -4. So 1, 2, 3, 4, plot a point. Then we're going to look at the slope. So b is -4. The slope is, there's no number in front of x that we can see, so it must be 1 or 1 over 1. So we're going to go up 1 over 1, up 1 over 1. So we've created 3 points on our graph there. And now I'm going to go ahead and draw the line. And again, the straighter the line, the better for these, because you want to know the exact intersection. And again, good practice to label your line. So this is y equals x minus 4. Okay, the next one, we're going to go to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They didn't really give us a whole lot of room to work with. And now we have the y-intercept is 10. And then we have a slope of -1 or -1 over 1. So we're going to go down 1 over 1. I'm sorry, down 1 over 1, down 1 over 1. Got us 3 points. I didn't do a very good job of writing my label. I'll put my label right in the way. But I'm going to go ahead and draw my graph this way. Again, I'm going to label my graph y equals -x plus 10. Now, what I want to do is, if you remember up there earlier, I see that these lines intersect. They intersect one time. If they're functions, they will only intersect one time. So since these lines intersect, I know I have one solution. Now, in order to solve my solution, I've got to find out where they intersect. What point do they intersect at? So I'm going to go right here, and here's my intersection point. Where do they cross? Intersection is where they cross. So where do they cross? Well, it's right here. So I put a point right there, and now I'm going to find out what that point is. Well, here's my x value. I'm going to go over 1, 2, 3, 4, 5, 6, 7 on my x, and then I'm going to go up 1, 2, 3 on my y. So this coordinate, or this ordered pair, is 7 over 3 up. So the solution to the system of equations, which is where they intersect, the one point in which they share on this particular system, is 7, 3. Notice, our solution here is not x equals something or y equals something. Our solution is actually an ordered pair or a point. Okay? And that is it. Okay, make sure you have that. If you have any questions, please make sure you write them down on your notes so that you can come in the morning during 825 tutoring or after school and ask about those questions. We'll be getting right into our activity on tomorrow.